Damn. Yeah.
Hello everybody, welcome to our channel. In this video, I will teach about Math Care SSM Form 4, Chapter 3, which is Logical Reasoning. In this chapter, you will learn about the statements and argument. 3.1 Statement. What is statement? A statement is a sentence of which the true value can be determined. That is either true or false, but not both. Here the example to determine within each sentences below is a statement or not a statement. The first question, 5 plus 4 equal to 6. As we can see, this sentence is false. It means that we can determine the true value. For this sentence is a statement. Now question B. What is a hobby? In this sentences, we can't determine the true value, so it will not be a statement. Now then, question C. Kuala Lumpur Tower is the tallest tower in Malaysia. For this sentence, we can determine the true value, which is true, so that it will be a statement. Question D. 4 plus y equal to 10. In this sentence, we can't determine the true value, so it will not be a statement, because we cannot determine the value of y. The last question. Please send the workbook. For this sentences, we can't determine the true value, so the answer is not a statement. After that, we will learn about how to determine the true value of the given statement. Here the example. For now, if the true value is false, we must prove it. Question A. 2x plus y equal to xy power 2. As we can see, the true value is false. But in order to improve our answer, we need to prove it. Let x equal to 2 and y equal to 3. 2 times 2 plus 3 equal to 7. Other one is 2 times 3 power 2 equal to 18. And now we can say that 2x plus y not equal to xy power 2 because 7 not equal to 18. Now then, question B. 2 times 6 plus 2 greater than 3 times 6 minus 8. To let you guys can easily to understand why the true value is true, I wrote down the step, although it is true. 2 times 6 plus 2 equal to 14. Other one is 3 times 6 minus 8 equal to 10. Now we can say that 14 is greater than 10. It is true. And now we will learn about how to determine within the following mathematics statement are true or false. Explain if it is false. Question A. Some perfect squares are whole numbers. For this answer is false. In the explanation we can write all perfect squares are whole numbers. Before we go to another question, I prepared some reference to let you guys refer back what is whole numbers and perfect square numbers. Whole numbers such as 0, 1, 2, 3, and so on. Number of perfect squares such as 2, 3, 4, and so on. Question B. Some polygons have 5 sides. Yes, it is true. The pentagon is a polygon that has 5 sides. Question C. All polygons have diagonals. It is false, because triangles do not have diagonals. The true statement is some polygons have diagonals. After that is how to negate a statement. We can use the word no or not to negate a statement. For example, question A. 25 is a perfect cube number. and the negation is 25 is not a perfect cube number. Question B. 15% of 200 is equal to 14. The negation is 50% of 200 is not equal to 14. Question C. 5 meter is equal to 15 cm. After the negation, 5 meter is not equal to 15 cm. And now we can notice that the true value changed from true or false through the process of negation. Furthermore, we standardize the true value of a compound statement. What is compound statement? A compound statement is a combination of two or more statements by using the word and or. Before we determine the true value of a compound statement, we need to learn how to combine the statement. Here the example. Question A. Statement P. Joe is running, and statement Q. Jamie is running. The combination of word and is Joe and Jamie are running, and the combination of word or is Joe or Jamie is running. Now then, question B. Statement P. My brother is going to school, and statement Q is my sister is going to school. The combination of word and is my brother and sister are going to school. And the combination of word or is my brother or sister is going to school. And now is determine the two statements from a compound statement. Question A. Anna and Ben are playing badminton. We can determine two statements, which is Anna is playing badminton and Ben is playing badminton. Question B. My mother or father is using computer. The first statement is my mother is using computer. The second statement is my father is using computer. After that, we finally can learn about how to determine the true value of a compound statement. Okay, now let us see the table below. In first line, P and Q are true. It means that the compound statement P and Q is true because both of them are studied. It means that the compound statement P or Q is true. Second line, P is true and Q is false. It means that compound statement P and Q is false because not both of them are studied. But the compound statement P or Q is true because one of them is studied. Third line is same situation like second line, so I'm not going for it. The fourth line, P and Q are false. It means that both of them don't study, so that the compound statement P and Q will be false, and compound statement P or Q also will be false. To let you guys more understanding in determining the true value of a compound statement, I prepared 4 questions example to go through. Question A. 4 or 10 is greater than 8. Before we determine the true value, let us list down the statement from the compound statement. First statement, 4 is greater than 8 is false. Second statement, 10 is greater than 8 is true. Then the compound statement is true because one of them is true. Question B. 12 and 29 is an odd number. Same step. List down the statement, then determine the true value. The compound statement is false because one of them is false. Question C. 10 plus 6 equal to 16 and 2 times 5 equal to 10. Same way, at last, you will get true for the compound statement because both of them are true. Question D. 5 or 7 is an even number. Okay, same way. Finally, you will get false for the compound statement because both of them are false. Now I will teach about construct a statement in the form of an implication. What is implication? A statement if P then Q is known as an implication where P is denoted as the antecedent, Q is denoted as the consequent. Now let us construct an implication with the given example. Antecedent is x equal to 10 and consequent is x is whole number. And then the implication will be if x equal to 10, then x is whole number. We need to determine the antecedent and consequent for the following implication. Example, if x minus y is greater than 0, then x greater than y. The antecedent is x minus y greater than 0, and the consequent is x is greater than y. After that, implication P if and only if Q. This is an implication P if and only if Q consists of the following two implications, which is if P then Q and if Q then P. Now let us form an implication P if and only if Q with the following implication. For example, first implication is if y equal to 6, then y is greater than 3. Second implication is if y is greater than 3, then y equal to 6. First step, we need to find out the antecedent and consequent. At last, you can easily write down the answer, which is y equal to 6 if and only if y is greater than 3. Next, we need to write two implications based on the implication P if and only if Q given below. Set less than 100 if and only if set minus 15 greater than 14. Write down the word of P and Q, then write down the two implications, which is if z less than 100, that z minus 15 greater than 14. And the second implication is if z minus 15 greater than 14, then z is less than 100. Now that is a part of construct and compare the true value of converse, inverse, and contrapositive of an implication. Before we go through the example, this is the format to write the converse, inverse, and contrapositive. Now, first step, write down the word of P and Q. Second step, do the negation to the P and Q. Third step, write down the converse, which is if x is less than 0, then z is a negative number, and inverse, which is if x is not a negative number, then x is not less than 0. And the last one, contrapositive, which is if x is not less than 0, that x is not a negative number. After that, then define the true value of statement, converse, inverse, and contrapositive of the implication. The true value of an implication, if P then Q, is always true, except when P is true and Q is false, happen at the same time. If an antecedent is false, then the implication, if P then Q, is always true, without depending on the true value of the consequent. Next, here we got an example. If 5 equal to 3 plus 2, then 10 minus 5 equal to 2. Let us see the table. Okay, in first row, we can see that 5 equal to 3 plus 2 is antecedent, and 10 minus 5 equal to 2 is consequent. As you can see, antecedent is true and consequent is false. It means that the true value is false. And then in second row, converse, we can see that antecedent is false and consequent is true. So that the true value must be true. After that, third row is same situation like second row, and the fourth row is same situation like first row. From this example, we can see that when the true value of antecedent is false, the true value of the statement must be true. But when antecedent is true, the true value will depend on the true value of consequent. Now then, a lesson about identifying a counterexample to negate the truth of a particular statement. For a false statement, at least one counterexample can be given to negate the truth of that statement. For example, question A. The sum of interior angles of all polygons is 118 degrees. The true value is false. And the counterexample you can write because the sum of interior angles of a pentagon is 514 degrees. Second question. 9 is an element of 4, 5, 8, 9. In negation, after negation, 9 is not an element of 4, 5, 8, 9. It is false. And you can write because 9 is an element of 4, 5, 8, 9. After we finish the part of statement, now we read the part of argument. What is argument? An argument is a process of making conclusion based on several given statements. The statements given are known as premises. An argument consists of premises and a conclusion. There are two types of arguments. They are deductive and inductive argument. Before we differentiate between deductive and inductive arguments, we need to learn how to differentiate the statements as specific statements or general statements. What is specific statement and general statement? The specific statements are statements that refer to a particular case, while the general statements are statements that describe a concept. Here we go to our example. Question A. The area of square ABCD is 9 square centimeter. It is specific statement. Because this statement only direct mention in form of this square ABCD. Next question. B. The volume of a cube equal to x power 3, where 3 is the edges of the cube. It is general, because this statement only describes a concept about volume of a cube. Third question. All even number can be divided by 2. It is general, because this statement only describes concept about even number. Last question. 20 is divisible by 5. It is specific statement, because this statement only direct mention in form of 20. After we know how to differentiate the statement as specific statement or general statement, now we can go through to deductive argument and inductive argument. What is deductive argument? Deductive argument is a process of making specific conclusion based on general premises. And what is inductive argument? Inductive argument is a process of making a general conclusion based on specific premises. Now then, determine within each argument below is a deductive or an inductive argument. Example, all regular polygons have sides of equal length. ABCDE is a regular polygon. Thus, ABCDE has sides of equal length. In this argument, we can find out a premise which is all regular polygons have sides of equal length, and conclusion which is thus ABCDE has sides of equal length. After that, identify the statement is a specific statement or general statement. As we can see, the premise is general, and the conclusion is specific. Alright, now we know that deductive argument is a process of making a specific conclusion based on general premise. So the answer is deductive argument. Another example, the sum of the digit in 44 is divisible by 11. Thus, the sum of the digit in multiplies of 11 is divisible by 11. Now, same way, list out the premise and conclusion. And then determine the statement is a specific statement or general statement. The premise is specified and conclusion is general. And the answer is inductive statement, because inductive agreement is a process of making a general conclusion based on specific premise. After that, determine and justify the validity of a deductive agreement, and hence determine whether the valid agreement is sound. A valid deductive agreement can be classified into three forms. Form 1. All A are B, C is A. In conclusion, C is B. Form 2. If P, then Q. P is true. In conclusion, Q is true. Form 3. If P, then Q. Not Q is true. Conclusion, not P is true. A deductive agreement is said to be sound if all the premise and the conclusion are true. In general, the validity of an agreement is determined based on the forms of agreement, and not based on the truth of the promises or the conclusion. To make more understanding to this part, let us see the example. Question 8. Premise 1. If x is less than 100, then x greater than 75. Premise 2. 85 less than 100. Conclusion is 85 greater than 75. The answer is valid and sound, because the agreement fulfills Form 2, and all the premise and conclusion are true. Second question. Premise 1 is if y is an odd number, then y minus 1 is an even number. Premise 2 is 5 plus 1 is an even number. Conclusion is 5 is an odd number. As we can see, the argument does not complete with a value of deductive, so it will not valid, but it will be sound because all the premise and conclusion are true. Then, form a valid deductive agreement for a situation. It is just a simple question. Okay, first question. All multiplies of 24 are even number. 144 is a multiply of 24. 144 is an even number. And then, list down the premise and conclusion. Premise 1 is all multiplies of 24 are even number. Premise 2 is 144 is a multiply of 24. Conclusion is 144 is an even number. Question B. If y is less than 0, then y has a negative number value. Negative 8 is less than 0. Negative 8 has a negative number. Here's the answer. Next, write a conclusion for each of the following deductive agreement to form a valid and sound deductive agreement. Let's go through the example. Question A. Premise 1. All even numbers are whole number. Premise 2. 26 is a whole number. To write a correct answer, you must follow the valid deductive agreement that classified into three forms. In order to write the conclusion, we use the formula of Form 1, which is 26 is an even number. Question B. Premise 1. If x minus 6 less than 10, then x greater than 10. Premise 2. 12 minus 6 less than 10. For this conclusion, we will use the formula of form 2, which is 12 greater than 10. Now, we write the premise for each of the following deductive argument to form a valid and sound deductive argument. Here we got an example. Premise 2, x greater than 6. Conclusion, x greater than 4. In this question, we will notice that now the question similar as form 2. So the premise 1 will be if x greater than 6, that x greater than 4. Okay, now question B. Premise 1. If polygon A is a pentagon, then polygon A has 5 vertices. Conclusion is polygon A has 5 vertices. This question also similar as form 2. So the answer is polygon A is a pentagon. Now determine and justify the string of an inductive argument, and once determined within the string argument is cogent. Inductive arguments in perhaps the validity of the arguments when an inductive argument in perhaps the string of the arguments. The string of an inductive argument is determined based on the probability that the conclusion is true, assuming that all premises are true. To determine an argument that is cogent or not cogent, it needs to be discussed based on the truth of the premises and its conclusion. In this diagram, if it is true conclusion, the argument will be strong and cogent or not cogent. But if it is false conclusion, the argument will be weak and not cogent. For example, question A. Premise 1, the table is made of wood. Premise 2, the chair is made of wood. Premise 3, the cupboard is made of wood. Conclusion, all furniture are made of wood. As we can see, all of the premise is true, but the conclusion is false. So the argument is weak and no cogent. Here we got another example. Power 3 times power 2 is k power 6. It is true. Power 4 times power 2 is k power 8. It is also true. And the conclusion is a formula that refers from premise 1 and 2. So the answer is strong and cogent. Next is form a strong inductive argument of a certain situation. A strong and cogent inductive argument depends on the true premises and conclusions. The given premises are the evidence or support to the conclusion made. Inductive reasoning can be carried out in the following steps. First step, observe some example or specified situations. Second step, observe the common features. Last step, make a general conclusion. Here's the example. Sequence 0.2, 0.04, and so on. 0.2 equal to 0.2 power 1, 0.04 equal to 0.2 power 2. From this inform, we can write a general conclusion, which is 0.2 power x, where x is 1, 2, 3, and so on. Last part for this chapter, which is solve problems involving logical reasoning. To improve more understanding, we straight to the example. The number of residents in Tamatesa follows the formula of G bracket X bracket equal to 215 bracket X power 2 plus X plus 100 bracket, where X is a number of years. It is given that the number of residents in Tamatesa on 1 January 2018 was 25,000. Question A. Make a deductive conclusion about the total number of residents in Tamatesa on 13/1 December 2020. Now we need to calculate the year that between 2018 to 2020, and we got 3 years. After that, let x equal to 3. After the formula, we got 28,000. And the last step, write a deductive conclusion, which is specific conclusion. The number of residents in Tamatesa on 13/1 December 2020 is 28,000. Now then, question B. In which year will the number of residents in Tamatesa reach 43,000? Same way, find out the year. Let G bracket X bracket to 43,000. After the formula, we got two answers, which is A and -9. We take A and ignore -9. And then plus 8 years from 2018 until it's done. And we got 2025. At last, you can write your conclusion, which is the number of residents in Tamatesa reached 43,000 in 2025. That's all about this chapter, and remember to subscribe our channel and share it to everybody. Bye bye.